Okay, let's also get started with the small crowd. Hi. Yeah, so second last week of Beginners Python for Engineers. And today we will be, okay, I see that I changed the week number, but not the title. Today we will be talking about plotting, writing and plotting data. Okay, let's see if my cursor works. Yeah, then just as always, I really would like to thank you, my group, because they did really a big part of this work, and it wouldn't have been possible without them. And I think it's important to give citations to the people who deserve it. So that's a good scientific practice in general. Like if you take something from someone, at least thank the people who did the actual work. So this is the group, which you also know from the TA, and I think they did a really great job. So now, what do you need to do? So next week, Monday, we have the project notebook deadline. I hope you're aware of that and you're working on all these cool questions you're asking. Like I looked at some of your submissions. I'm actually very interested to see what comes out of your group projects. And the deadline for that is next Monday at 6. And the same is true for the homework of week 5. It's a rather short homework, so this shouldn't be bothering too much that it's the same time, the deadline. It's easier to remember, Monday at 6. Then the next lecture will be a bit special. And the reason for that is that it's part for you to present your work. So one of the teams, it's mandatory that one of the team is present to present it. Of course, I highly recommend for everyone to show up to see what other did and to learn how other people approached a task and solved it. And what do I expect in this presentation? So there are, I basically just want you to present what you did in the project, what were your findings and whatnot, but it should definitely include which data sets did you use, what question did you originally want to answer? Then also you should present the answer, even if you maybe couldn't answer it, but you found something else, present what you found. And then whatever was interesting, funny, odd, or I don't know, even frustrating, I'm just interested in how it was going, and whatever you would like to share that's also beneficial for others can also be shared. The whole presentation per group is 5 minutes. It's up to you how you do it. I usually think it's beneficial if only one person presents the whole thing, if it's such a small time, but if you want to take part in presenting different parts, I'm also fine if several people present their findings. Yes, and then also a thing we shouldn't forget about, your project will be peer reviewed by another student, and the peer review deadline is the 28th of June. This will be done in my courses, so each one of you gets a project assigned from another group, and you have to go through these bullet points we gave you and check what you think of the other person's project. This is also, again, like not a group work, like you don't go through it as a group, but this is individual work. Yeah, and then this course will be over already. So for me, it actually went quite fast, and I hope that you could learn something. And I think there is much more that's worth to explore in Python, but maybe next year we get a longer course. Okay, so let's do something about today. The general, like feel free to join with video, especially today, we're not many people. If you're shy, you don't need to. Then you can also just open the microphone and ask if you have a question at hand, or write it to the chat. And yeah, we'll record it and we'll put it unlisted on YouTube. And again, next week, special edition with the group presentations. So this is just, again, the overview. So we're now in the very last chapter about output. And today we will look a bit at plotting. The structure, we first look at how to write something with Python. For people who have taken the introduction or the basics course in programming, they will already know this part. but then we will talk about how to build up a plot from scratch with matplotlib, because this is like the holy grail in plotting in Python. And then last but not least, we'll look a bit more elaborate plots in the end. So as a very first thing, you have to ask yourself, what actually do I write and how? And it highly depends on what you want to do with the data later on. So if you just want to store your work, like you did some work, you did some calculation, and you want to store the package you have at hand, and you want to work later on it, also with Python, then just pickle it. Like we got to know this pickle library, and this is very convenient to save something as a Python variable. It's very fast in loading, and it's very low effort to every now and then store this timestamp as a pickle. If you have like finished a certain step on your project, let's say you cleaned all your data, and maybe you go back to this set of data that you have now in this state, then it makes sense to not only pickle it, but also save it in a format that other programs can work with, so that you can also maybe share it. So there, I highly recommend to use CSV files, because they are super efficient, super effective, and basically every program that works with data can open it. And generally, always save your intermediate steps. Like if you spend some effort into reaching this step, save it so you don't lose it. And in order for it to be useful for you, make sure that you name your files properly, so that even when you go back later, that you will still know what is in this file and what have you done to the file. So I usually have very long file names, because I often plug a lot of information into the file name. It looks a bit ugly in the directory, but on the plus side, if I have the file, then I am pretty sure that this is what's in the file. Also, another thing is, like, you can always save the data in the file format you got it originally with, because often, like if you get a task, like someone gives you data and says, okay, do this with it and give it back, then they often would like to have the same structure back. And yeah, that's another thing. Then again, I'm a huge fan of CSVs, because they are super easy, super efficient, and you can also read them with all kinds of text editor programs. And again, like, you have to be very strict with naming and the folder structure. Like, make sure that you have folders for the original data, for the clean data, and for the end results. Because especially if you start to automatize, you can also automatize a lot of things. Like with Python, you can open certain file names and change something and write it back and whatnot. And if you start doing these things, there can always be mistakes. And it can always happen that you kind of overwrite part of the data you still need. And this is very frustrating. So be very careful with that. And also with like that you actually set up this order structure and use it. The same, actually, what I highly recommend, and I'm guilty of basically never doing it, is write a README file. So in a README file, what one does is one describes, like, where did you get the data from? What is in the data? Then you also describe what your program does. Like if you write the program that reads in a certain data and outputs something, then you write, okay, this program expects this data to be in CSV format. It should include this and that. And then it calculates this and that, and then it stores it there. And if you summarize all of these in a README, you can always, when you come back to your project later on and you don't remember what happened, you can guide yourself on actually getting up to speed again pretty fast. And this actually saved more than one of my projects, because I had coworkers who were actually great at writing the README files. Yeah, so do that. Then generally another thing what you have to consider when you write data is like this balance between consistency and ease of use. And what do I mean by that? Like if you have one big file and you do all the manipulations always with this file, like you load the whole file into your data frame and you do all the calculations and the cleaning and whatnot, then you will never have the problem that you have different time steps of this file. Like, you know, okay, I did it to the whole data set. You don't have data that is not cleaned and data that is cleaned, and you don't mix them up in some way. So that's super convenient because you know it's consistent. But of course, it takes a lot of space and a lot of time to load it and to handle it, because let's say you're only interested in the average temperature of something, but you always treat the whole data with the rain and the highest temperature and whatnot, then you you lose a lot of space and a lot of time for basically nothing. So it can make sense that you store only parts of the data, but it of course comes with the downside that you have to make sure that you stay consistent, or if you don't stay consistent with certain data, that you're aware of it. So again, be very strict with naming and keeping track of what you did to the data when you store separate parts of the data. Especially if you want to fill a database with the data, it makes a lot of sense to have a lot of smaller chunks of data rather than one big file. Mainly because there are a lot of functional dependencies you want to avoid and redundancies. So it's a good thing to make smaller parts. And of course, you should follow your data scheme for that. And then it's best to immediately write it to a database. And you can do that with Python. And for people who are interested in that, there is this database course offered by Aalto, where you will learn all of this. And especially if you choose to have several smaller files, really write this README text file. It helps so much for later on to figure out what you were actually doing when you were working on the project. And even though it maybe happens to you that you think, yeah, I mean, I'm working on this project and once it's over, it's going to be over. I can tell you that I came back to my old projects over and over again, because suddenly you change jobs, or you suddenly have a follow-up idea to something you were doing on some point. And then it's just super nice if you can reuse what you've already done. But if you leave behind yourself a huge mess of things you don't remember anymore, then this is just not possible. So really keep your data and your structure clean, and be very verbose about what is where and how. Don't think that I ever heard anyone complaining that he wrote too much of the details into this data file. Okay, but now let's have a look how this actually looks in practice. Yeah, first writing. How do you do that? Like what I usually like to do, I first like to define the file location. If you have this in a variable, it's also easier to keep track and change if you often reuse it. So you can let this run. And then this is the very standard thing to write in Python. So you just say open the file, and then you give as a parameter v. This means write, and then you write something, and then you close the file. So let me quickly show you what happens in the inside folder. So here you see this folder. It's empty now at the beginning. So let me now run it, and let me show you the folder again. So now you see that this my file in this exa folder was written. So, and if I open it, you can see what we wrote to it. Okay, of course it's open on this other window. So you can see here that it wrote this hello world. Okay, now let's see what happens when we now do this again. Like, let's change a bit what we write here. Let's say just hello world, and let's write it again. And now let me show you again what's happening here to the file. So the file tells me that it was changed, so I reload it, and now you can see that it writes again the same thing here. So there is not now several lines, but it really just, it takes this file, it opens it, and it overwrites everything. In case you want to add something to your file, you shouldn't open it with the W option, but with the append option. So let me try it here. So if I change this here to append, and then I say here, hello world should be appended, and I run this. Now let's see how this file looks like now. And here you can now see hello world should be appended. So it did append it without deleting the first part. So this is the difference between the parameter W or the parameter append. Often it makes sense to write the file from scratch. And you don't necessarily want to have old stuff, but sometimes you just want to have additional stuff to your file, then you can use the append. Okay, then if you're like me, you will sometimes forget to close the file. So you can again go with this structure that you say with open file location and then write it like that. So this will just write it again. So if you want to see, it now opened and overwrote my file here with just this hello world. So now you're maybe wondering what happens if you actually forget to close your file. And for that, let me quickly show here the, maybe I can make this not that big so that you can see both at once. I hope you see both at once. Let me know if not. So now I want to open this file that is called my file no close, and I want to write into it that I never close my file. So let me run this code here now. And now you see in my order, in my folder, this my file no close shows up. So it's written. So I have here a file with this title. But if I open this file, what actually happens is this. You cannot find anything in here. And does any one of you know why this is the case? Why, like I wrote it here, like I said file.write, but nothing's in my file. Does anyone know why this is the case? Buffering, exactly. So what Python does, it has a buffer. So it first writes to this buffer. And once the buffer is full, it actually writes to the disk. And why is this the case? So in our computer, we have different kind of memory, and they differ a lot in how persistent they are and how easy they are to be accessed. And some parts we can easily access, and some parts are quite expensive time-wise to access. And that's why Python tries to not always do a disk access, like to write it into this file. This is a disk access. So it doesn't want to do it for every letter we want to write to it. It only wants to do it every once in a while to make sure nothing is lost, but not instantaneous. But sometimes you maybe want to have something written down immediately. So Python offers this thing that it says this flush function. This just flushes the buffer to the disk. And you can use it whenever it's important to you that it's actually written immediately to the disk. So now if I run this, here my file reloads. And if I watch now, I can see that I never close my file. It's now here. Another thing when Python is triggered to write the buffer is actually if you close the file. So here, I mean, you can maybe just do this again. Check here. Now the file is empty again because we opened it, we wrote something to the buffer, but not to the file. And then if we say here, file.close, if we close the file, Python makes sure that it's actually written to the disk. So it appears here. And why is this important to keep in mind? So if you do super complicated computations and it takes a while, make sure that you flush it to the disk later on, because it could always be that your computer crashes, or if you do something where you connect to some server to do some of the calculation and this connection breaks down, that your work is lost if you don't flush it. So flushing is a good thing. And also closing the file is a very good thing. Okay, another thing you should be doing is there can always be operating system errors when you do writing and reading from files. So it's always a good thing to do this try and catch around it, or like that's actually a Java term. Like in Python, it's try and accept. So what this does is nothing else than it tries to do that. And if it doesn't succeed because of an error thrown by the operating system, it informs you. And that's often very important also if you have running computations. You want to know if something's not working with your file writing, not that you kind of are happy enjoying that your computer is working for you, and in the end you figure out that it never ever even started because there was an error. But like that, you can catch this and be informed about it before any damage is done. We will not go into detail here. That's just something you should look up when you do programming with a bit bigger things. Okay, now I can make this bigger again. So better than writing by hand is of course using libraries to do the writing for you, because you most of the time you don't want to format these strings yourself in the way the structure you want in the end. And there are a lot of nice tools and libraries. So for example, as we already got to know, pickle. So we can run pickle. Now we store this dictionary. Dictionary is a Python type. And if we load it again, then Python knows it already as a dictionary. So if you are interested how it looks like, so here is now this file docs. And if I open it in my text editor, you can see that my text editor doesn't really know what to do. But because we're going to use the pickle again with Python, it will be loaded equally nicely as a dictionary again as previously. Also, of course, pandas has a lot of writing instructions. So for example, here we make this docs that we just defined as a data frame. And now I can write this docs to a CSV file, also to a pickle from pandas, or to a JSON or an Excel. So whatever you want, I can do that. And it will appear here in this. Okay, here you can now see that we wrote down this this doc file in a CSV file. Yeah, and these are just like the other commands to do the certain formats. So I I wish you a lot of fun to do that, but I don't think it makes sense to show each single one of them. Okay, so this was it from the writing. And let me see, yeah, we're at 20 minutes, so quickly stand up, drink a bit of water to to get it on. Okay. And I will go back to my presentation. So I hope you can see the last slide we looked at. So, and now the next thing I want to discuss with you are plots. And for that, there are some things every plot should have. And I would like to know from you what you think. What does a plot need to have? And when I say plot, I mean like these graphs, this representation of data, where you have, I don't know, usually colors and axes and information. So what do you think a good plot has to provide for it to be useful? And I'm watching the chat to see. Okay, so first answer, axis, auto and manual scaling, a legend, axis units, axis values, title. Yes, all of them are very important, and unfortunately not everyone does them. So let me press one further thing to see what I wrote down here. So yes, so when you wrote axis, Marco, I guess you also meant that the axis should be labeled. So if you have a y and an x, you should say, what do you see on the x? What do you see on the y? Because otherwise it doesn't make much sense if you don't even know what is the thing we're looking at. Auto and manual scaling, I'm not exactly sure what you mean by that, but I guess that one should see the data in it, that it's scaled in a way that it makes sense. Yeah, if you want to be more detailed, feel free.
Yeah, can you hear me?
Yes, I can hear you.
Oh, yeah, I meant, I don't know, for example, many graph, you don't need to specify what is the minimum. Usually minimum could be 0, that could be something else, and the maximum be whatever, and you want basically sometimes to specify what is the maximum, or if it's an intelligent graphing system, it's automatically do the scaling of the minimum and the maximum.
Yes, okay. Yeah, very well. So the tool we're looking at, like matplotlib, actually does this automatically, like it adapts it according to the given data it has. But here I also, like, you can of course force it to take a certain minimum or maximum, and here you can also see in the real world, a lot of people are abusing this to show the data in a certain skewed way. For example, if you don't start your plot at the 0, but you started at 4,000, then if you compare a value of 4,500 and 4,570, the difference looks very big. Even though if you would see the whole graph, it's basically, you couldn't tell the difference. And yeah, be careful with that, because I think one should be truthful and trying to stick to truth. So matplotlib does it by itself, but you can force it to change these things, these settings. And yes, it's highly recommended to use 0 as the starting, because this is what the human brain is used to. Then legend, yeah, so a legend is a description of what you actually see on this, and this is also very important. It should describe it. Axis units, this is one that is very close to my heart, and a lot of people leave it out. It's so important to, if you look at data, like it matters if it's liters or cubic meters. It's not the same, and if it doesn't say which are the units, the graph is basically not good for much, because it could be this big or this small, because you don't know. Yeah, then axis values. Yes, we'll talk about this a bit as well. Like you should know what are the axis values. Like if you have this axis going from somewhere to somewhere, also with the liter or the cubic meters, it matters if it's like if it's going linear, like 1, 2, 3, 4, 5, or if it's logarithmic. Or exponential, and all these kinds of things, because it actually really changes what the graph shows. And if you don't tell the people what it is, this is basically lying about the data. And the title. Yes, so title, super, super important. Like if you look at the graph, you want to get a first context for your brain to figure out what am I seeing. And if you leave that out, you have to go step by step. Like, what are the axes? What is the thing? And it's so easy if you just write in the title, look, this is what you're seeing. Then I immediately know what I'm supposed to be seeing. And last but not least, Panu wrote that it's a common way to cheat with graphs, start from 1 to 100 and other from 90 to 100. It's easier to think a small change looks huge in the latter, which is it's minuscule in the first. Yes, exactly. So graphs are super nice to get a quick overview of things, but it's also super easy to cheat with them. And don't do the cheating. When you see graphs, question them, like wonder who did it and why, and if there is maybe cheating involved. And so, yeah, very, very good points. So what I wrote down here as well is the name for the axis, the units, the legends, the title. And then I also added save your figure, like once you produced it, also save it so that you have access to it later on. And again, put the description in the file name, because if your plots are called plot 1, plot 2, plot 3, the same will happen as happened to me with your exercise session, right? There was a mix up with the plots, like we had a total different plot in the exercise session than the plot we were actually talking to. And things like that happen if you take a really bad naming. So name your plots the way you know what's in there. Okay, so let's go back to the notebook. I hope you can see now my notebook again. So, okay, here we now reach the plotting area. So yeah, with Python, matplotlib is the most common used one. There are other other libraries available as well. So choose what fits you. But with matplotlib, you're basically on the safe side, because it gives you a lot of possibilities to do things, and there are a lot of people who help you in the real world. So if you ever have a question how to plot something, there are a lot of people who will answer. Also, what I usually do if I want to do a certain plot, I just search for it, and I will copy paste the code someone has and adapt it to my own needs, because this is usually a less frustrating way than building from scratch. But we will look at it, how to build it from scratch. So what you first have to do is you have to import matplotlib. And here we import NumPy just to show you some graphs. So you don't need it to the plot, but because of the graphs we want to show, we import it here as well. And then as a first thing, what do you actually want to plot? And it's usually here now that you name it X and Y, if you have some X and Y axis. So for example, here for X, we take the integers in range 0 to 100 or whatever range you want. And then here we now chose the square root function of Y as a function to plot. And now it's very easy to get your first plot. So you can just say PLT. So this PLT is the abbreviation for the matplotlib, and it's also standard that people choose it that way. You can now just say, okay, plot X and Y. And oops, if you run this, you already get like your first plot. And it's very straightforward, very easy. Then, as we just discussed, we of course want to add all these musts for plots. So we don't want to stick here, but we want to add axes and labels and whatnot. And for that, we need to have an axis object. So matplotlib works with figure and axis objects, and you get access to them with this statement. So this will assign the from subplots. We will also need subplots later if you want to plot several functions next to each other, but we also need it to get access to name the axis, even if you don't have more than one plot. So this is how you get access to it. You just say fig x, and this is also very standard, like most people call these variables this name. And now let's start. Let's just set the x label. So this is the label for the x-axis down here. And now let's call them positive integers and run. So now we already have our first plot with the x label here. And as you can guess, like the y label does nothing else than label the y-axis. Let me show how this looks like. So now we have this x-axis and the y-axis. And now, as you said, we should have a title. So let's add a title. It's also pretty straightforward. It's called ax.setTitle. And then you can just div a string, and this string will then be the title. So if we run it, you can now see that we got a title for our plot. And now, as someone said, we should have a label for it. Let's do that. So now we say ax plot xy, and then the label is a string. Oh, and now we see nothing happened. So we didn't get the label. And this is because we have to tell matplotlib that it should show the legend. So we have to add this ax.legend. So here we just gave it the label, but we didn't say that it should use it. So this basically tells it to use it. So if we use it with that, then we get here this label for the square root function. What we can also do, we can say that we want to not have it up here. This is the standard, but that we want to have it down here. So if we want to do that, let me take it out here. No. What am I doing? Nothing, I should. So what I wanted to show is if instead of this ax.legend, without the parameter, I can give this as a parameter where I actually want to have the legend. There you can say like lower right, upper right, and all these kinds of things. So now you see it's in the lower right, so we put it here. And last but not least, you can of course also change the color of the plot. And you can do that, for example, by just saying here what the color is supposed to be. Let me get this out. So here we just say again, this plot, and then we give it the label and the color. And let's run. And now you can see that it turned blue. And set, save your figure. So we save it here. And with this fig.savefig, like this fig is this variable we got here from the subplots. And now you can see here, my figure showed up here. You can see my square root function as a figure. If I open this, you will have here this PNG format of your plot, and you can include it in a report or however you want to communicate with your plots. So this is all very, very nice and straightforward. And now that we worked a lot with pandas, plotting with pandas can also be done. Like pandas has a lot of wrappers around the matplotlib. So the ground is the matplotlib, but it also provides a bit of nicer interface to actually use it for some of the plots. And in order to show you how this is done, I will now again load this very original weather data set we looked at a while ago. So let me run it. So here is this stations and the precipitation, the dates, elevation and whatnot. And now if we plot it, this is what happens. So maybe you will be now a bit confused because it's not very nice looking, but what it does is, as the x-axis, it takes the index. And here in this thing, the index is just the integers from 0 to the length of the data frame. And then for each column, like here are the column station name, latitude, longitude, and whatnot. For each column, it prints the values. And here the legend on top of it. So latitude, longitude. So all the titles are basically now here printed. And it does this with the values that actually make sense. So it cannot print strings, for example. Of course, this is not very helpful as a first, but we can also just look at one column. So let's look at the average temperature. If we look at that, it looks already a bit better as an overview, but it's also still like, this will not really tell you much about this average temperature. So what we, for example, want to do with the average temperatures is to plot a histogram. Now I have no clue how many of you already know what a histogram is. So let me give you a very quick introduction to a histogram. So a histogram, you can imagine that you have like, let's say you have data, let's say age of people, and you have it from 0 to 150 or so. And now you're wondering how many people are in which age group. So you group the ages into groups. So you say 0 to 10, 10 to 20, 20 to 30, and then you just count how many people are in these groups. And then you get this histogram. So in pandas now I do this with the average temperature, and the bins is the number of these ranges I want to have, and I can just tell pandas the number of this, and it will then distribute them evenly along the axis of the values it finds. And for example, if you see here with the average temperature, you can see that we have quite some values here between 35 and 40. And also 60 to 65 seems to be quite many of the average temperatures. This already tells us that this is not in Celsius, but in Fahrenheit, because otherwise we couldn't have so high average temperatures. Yeah, and this already gives a very nice overview of data. And this helps you also to get a quick overview of your data. You can always plot like parts of your data frame in this way. Then another important tool, especially in social sciences. So I also don't know how many of you are familiar with box plots. It's basically what's used in statistics often, and social sciences use a lot of statistics. So what it does, it takes all the values and it calculates what's the median, like the, not exactly the average, but the median is like the value that if you order it is in the middle. So this is this green line. And then 75% of the data are between this end and this end. So the 25th smallest and the 75 highest value is here. And all this is like given here. And then this little thing shows about the outliers and how far the distribution goes. This is a tool that's often used to compare distributions. I used it now here on longitude and latitude. I don't think it makes a lot of sense, but what you can see is that the weather stations we chose, they are more widely spread on the west-east than on the south-north scale, which also makes a lot of sense because I chose like the world is not equally distributed with the land on the planet Earth, and this is reflected here. But it's more like here to show that it's quite easy with pandas to get such plots out. Then, for example, if you have two values that are somewhat correlated to each other, a scatter plot is a nice thing to look at. So here, let me plot it. So here, what the scatter plot does, it just now takes one of the columns is the x-axis and the other column is the y-axis, and it can show you if these points are somehow correlated or if they are widely distributed. So for example, this is now, as I took the longitude and the latitude, it basically shows you how widely distributed these metro stations were. So you can see that they were more in the north than in the south, but that we had north and south and east and west different weather stations. What is maybe more interesting than the distribution of our longitude and latitude is if we want to look at the average temperature and the latitude. So latitude tells us how much north or how much south something is. And then if we now do this scatter plot with the average temperature and the latitude, we can basically see if the average temperature depends on if you're up north or down south and how much it actually depends on that. And it seems like that there is some correlation. So the higher north seems to be a bit colder than here in the south. But also when you look here, there is quite some outliers. So it's not so clear if the average temperature is only dependent on the longitude, latitude. Yeah, but these are things one can do with pandas, pretty easy and straightforward. Are there questions so far? No. So it's now sharp 3. So I recommend that we take a 2-minute break. I will be back in 2 minutes. Get up a bit, move a bit, drink some water. It's a hot day, and see you in 2 minutes. Okay, so it's time to continue. So now we've seen how to build a plot from scratch, and we've seen how pandas has some wrapper functions where you can easily access some of your data, especially column-wise. And now I want to just show you some of the possibilities we have with matplotlib. So for example, if we want to compare two functions, we want to have them next to each other or more than one function in the same graph. And we can do that. We can again do this with these subplots. So let's say, for example, here, I even take 3 functions. Like we have the square root function as our first function. Then this y2 is now defined with a lambda. I hope you still remember how lambda works. So what it does is takes the x and squares it and gives it back to a list. Then y3 is the cube function. So this here is squared and this is cubed. And now when we build the plot, we again go for this axis object and the figure object with this command plot like matplotlib subplots. Then we set the x label and the y label. Then we set the typle. And now we plot all 3 of them. And how do we do it? So we can just say plot and then add this x and y with the label that goes with it and with a certain color. Then we can just add the same again with the same x, because we all want to have them in the same x axis direction. And then we have here the square function, of course, as title, and we have to choose red. So if you don't choose the color, then you will have 3 times the same color, and it will be difficult for you to figure out which one of them it actually is. So always make sure that you label them and that you give them a color. And now again, the same for the third. We name it cube function, give it color green, the legend in the upper left, and let's run it. And now you see this picture. So it has all the things we wanted. It has a title, it has legends. But now what you can see is that this cube function grows so much faster that you cannot really see if there is any difference between the square function and the square root function. But of course, we know the square root function is much smaller than the square function. So it's a bit awkward to not see it here. So this is apparently not a good way to plot it if you actually want to see the difference between these curves. So one thing that already came up in the chat is that we can, of course, take a different scale. So here we can set this to a log scale. And what happens now is that we can actually see the differences of these very, very well. And now what I definitely should change. So now here you can see that this here is the log scale. So there is a 0, 20, 40, 60, 80. 100, and here is 10, 10 to the power of 1, 10 to the power of 2. So this is not linear anymore. And of course, we should write this down in the title, because otherwise, if people will look at it, they will not be immediately aware of it. So we should write log scale plot of the square root and square functions. Then, yeah, this is the way to do it if you have several graphs in the same picture. Then now, these plots I showed you before with pandas, we can also simulate with matplotlib. So here is one version how to do it if we want to have the bar plot. So as an example, here is now different languages, and the students were asked, what is your favorite language? And then we now just plot the number of students for each of the languages. And here, with this fig add axis, so previously we had natural x. So because it was just the natural numbers. But now with these favorite programming languages, we cannot use like the natural numbers from 1 to 0. It doesn't make much sense as an x-axis. So we have to add an x-axis, and you can do this by just saying this ax object is fig.addAxis. And these numbers here now is what was actually also mentioned in the chat. So this here tells you what is the like how big shall it be? Like there is the minimum and the maximum in the x-axis, and the distance to the corner top here. So for example, what I can do here is I can make one of them bigger, and then you can see what happens. So this is what happens. So you can scale this to have different shapes. Let's put it back to 1 because it looks a bit ugly. So elongated. Okay. Yeah, then here the x-axis is these languages, and then the students is just a number. And here it's set again automatically by matplotlib, like it starts at 0 and it puts the number here, the max. Now let's say we have this same thing, but we want to compare 2 subgroups of students. For example, electrical engineering and chemical engineering. Maybe they have different favorite programming languages. So what I can do, I can define here the electrical engineering favorite languages, the chemical engineering favorite languages. And now I do again a bar plot. But what I do is I put them next to each other. And how you do it, you can say here, plot.bar, and then you say x-axis minus 0.2. So this just means it moves this LX student bar a bit to the left. And then here we have plus 0.2, so it moves the chem students a bit to the right, so that these 2 plots look very nicely aligned. So this was moved left and this was moved right. So you can see what happens if I would move it a bit less. So you can now see that they are basically into each other because I didn't move it so that they fit. And with these things, you can play around until you like what you see. And then what is often also that people want to see, like now we see, okay, the LX students have Python as their favorite language. And for the chem students, it's more like C++. But maybe you're interested still in what is the total, like if I look at all of the students simultaneously. So what you maybe want to do, instead of having this comparison bar plot, you maybe want to have a stacked bar plot. The stacked bar plot is nothing else than you stack the bars on top of each other, so that you have, on the one hand side, you have like this information of which students chose what, but you also have which is the favorite language over all of the students. And in order to do that, one of the things we can do is we can just say that here, like this is where we play where we paint the chem students. So here we just said it should plot it, but now we will add this bottom is YLEC. This means that the bottom of the bar of the chem student is the value of the YLEC. So this will put it up here. Okay, now I don't know what I did. Here. Okay, let's see what happens now. And now you can see this stacked bar plot, which is very nice because now you immediately see, okay, Python, if I look at all the students, Python is really the thing we like. Of course, now I would have to move them again a bit to the right because now they are not that nicely aligned anymore with this label. But this is the things you can do here in this plot bar where you arrange them. You can arrange them accordingly. Then, of course, matplotlib also has the ability to do a histogram. Here I took actually an age array. So here we have all different ages of a certain community, and I can define how many bins I want, like how many age groups am I interested, let's say 10. In order to do so, this is the important line for the histogram. So you say n and bins to get this properly assigned. The rest is the same as you know it. And if I run it, you get this. And if you want to have now a less fine-grained thing, you maybe are only interested in 5 age groups, then you can go here and say, okay, the number of bins is only 5. And then you get something like that. Or let's say you're interested in more fine grade, like you can say that you have 20 bins, and then you get something like that. And this is known as a histogram, and I think it gives you a really nice overview of how the values are distributed over a certain range. Then one thing I like a lot, it's a so-called heat map. There you have to be careful, like not all of the things make sense as a heat map, but if you have something that has some meaning in the column or in the row it is, then this is a really nice way to get a nice overview of your data. So what I took here as an example is grades. So let's say Sam has some grades, Jasmine has some grades, like all the students have some grades, Remo and Hans. And the grades array is just like all of these in one array. And let's say that they are also ordered. Let's say like the first grade in the array is always for the first course and the second for the second course and whatnot. And now I can make a heat map. And what it means is like here, it just assigns a brighter color the higher the number is. So here we only have numbers from 1 to 5 because these are the grades here. But of course, this can also be more fine-grained. And this is a nice representation because we work really well with perceiving colors and feelings about that. So here you can immediately see that these courses, like course 3 to course 7, seem to be easier than the others because here most of the students got high grades. And you can also see that this course and these courses seem to be a bit more difficult because they are darker red. And you can also see that, for example, Hans seems to be an atypical student, so he didn't perform very well in these courses where everyone else was performing well, but he was performing very well on the other courses. And of course, here you can also change all kinds of things. So maybe one thing that's important is also how you set these names, and here that the names of the students, so that you actually can check or that you know what you're seeing. So this was done with here. You can see that student names is just an array with the strings in it. I mean the courses as well. And then you can set the X ticks, like these are these how do you call them? Now I'm missing the word. These are these things like the ticks. And you can take these so long that it fits the length you need for your strings. And then you can arrange them in that way. So you can set them, then you can say the labels for the ticks is the courses, which is this string here. And then it assigns it here in the middle of every one of them, which is very nice. Yeah, and now last but not least, the infamous pie chart. So I don't know why they are so super popular, because I think pie charts are usually not giving a lot of information about things. And they only basically work if everything sums up to 100%, because otherwise having like this full circle, if you don't want to represent 100% of something, is even more awkward. But I think a lot of people use them because they are easy to find in the Excel, or a lot of managers like pie charts. But this is how you do them if someone needs them. So you can again go with this figure and axis object from the subplots. Then here again, this is now the languages and the number of students. And then you can just say plot pi and say what you want to print, and then matplotlib does the rest for you. So it can do these pie charts, but before you use them, make sure that they actually make sense to be used. Because, for example, here, I don't think it makes sense to say the favorite language and then use a pie chart, but you can do it if you feel like it. And I see that I'm now a bit over time, but we're at the end of the lecture with that. And yeah, if there are questions, I'm happy to answer. Otherwise, make sure you get your project done, and make sure you inform your team about the upcoming project presentation next week. And yeah, we will see again next week. Okay, seems to have no questions. So have a nice evening and enjoy a bit of the sun.